Once again, welcome everyone to the webinar on Geomatica 2017. We're pleased that you could join us today. We will be presenting an overview of the latest release of PCI Geomatics desktop software, which is Geomatica 2017. It's a very important release for us. We have spent considerable amounts of effort on developing this particular version. And we'll be going through the details on that. So if I can get the next slide. The key things that are part of the Geomatica 2017 release are listed here. And as you can see, we have two brand new modules that address key concerns in Earth observation, key application areas, and image analysis. And really the benefit of 2017, or the addition of these two modules, brings Geomatica back into the realm in terms of performing advanced analysis on images. So Object Analyst is a object-based image analysis tool which allows you to segment the image into objects and then also perform the classification. InSAR is our interferometric module. This allows you to use repeat pass synthetic aperture radar imagery to measure deformation and also to extract elevation models. We'll also be covering updates to OrthoEngine, which are included in this version. And as always, we will be adding additional, we have added additional sensors to the long list of sensors that are supported in Geomatica. So we'll be presenting those as well. Now, just a quick, next slide, please. A quick few words on the presenters today. So myself on the right, Kevin Jones, I'm the Director of Marketing and Communications for PCI. I've been with the company for several years, and it's my pleasure to be here today to present to you the latest version of Geomatica 2017. Together with me, and actually our main presenter, is going to be David Pickney. David also has been with the company quite a long time, and he is currently serving as our product marketing manager. And David covers the product marketing management responsibilities for all of PCI's products, including GeoImaging Accelerator, Geomatica, and our developer platform, and everything that we offer. And so David will be the main presenter today, and I'll be assisting him. Just a few words on logistics. So the lines are muted during the presentation, so you can make noise, or you can speak. If there's more than one person in the room, you can have a conversation about what you're seeing, no problem. If you have any questions throughout the webinar, just type them into the questions panel. And we will be having a Q&A session at the end. So make sure to enter your questions as you have them throughout the session. And then we will go through them, myself and David will go through them at the end and make sure that we address everything that you have asked. And we are recording the session. We do have someone recording the session. We'll be posting it within the next 24 to 48 hours. And so if you want to share it with colleagues, you can do that, no problem. But if you're here with us and you made the time, we thank you for doing that, and we look forward to going through the session. So without further ado, next slide. We just want to start the session off with a quick poll. So the first thing we'd like to know is kind of the main motivation for being here today. You've probably saw the announcement about our new software release, so if you could let us know if any of those things have kind of piqued your interest, and that's the main reason why you're here. For example, learning about object-based image classification, maybe it's InSAR, perhaps it's OrthoEngine and the sensor updates that are being presented today, or maybe you just want to know in general what's up with PCI Geomatics and the latest news on our company. And if there's another reason, then by all means, you can type that into the questions panel and just let us know what that other reason might be. We'd be glad to hear from you. And I'm just going to leave that open for a few more moments. Looks like most people have answered the poll, so I'm just going to count down from 3, 2, 1, and I'm going to close it. and just quickly share the results for you. And you can see that looks like a pretty even share, but quite a few people are interested in Object Analyst, which is great to see. So without further ado, I'm going to pass it back to David, I'll pass it to David for the first time to present to you some of these new updates.
Great, thank you very much, Kevin. For those of you not familiar with PCI Geomatics, we're geospatial software experts who provide commercial and educational desktop packages, developer tools in the Geomatica Developer Edition, and enterprise solutions, including cloud, for image processing and analysis in the GXL, or Geoimaging Accelerated. We have a wide variety of offerings, and today we'll be looking at what's new in our desktop suite, Geomatica 2017, starting with Object Analyst. So Object Analyst is a brand new package for image segmentation, classification, and feature extraction. The main focus here is the image processing and analysis in a easy-to-use interface. Sometimes this technology or suite is known as object-based image analysis, or BIA, object-based image analysis. You may have called it object segmentation or feature extraction, all of these things. This is now part of the Geomatica 2017 suite as an add-on package that's now available. So what this means for you is we're moving from a per pixel based classifier, which is purely multispectral, into the realm of object-based intelligence. So now not only looking at the spectral values for various pixels, but also at their relationship to the pixels around them, looking at the groupings of the pixels, their homogeneity, their shape, their texture, and various other aspects that provide more intelligence or more knowledge about what those objects actually are. So moving from a set of interconnected pixels to actual grouped objects with distinct relationships to one another. As I mentioned, the main focus of Object Analyst, apart from the segmentation itself, is that it be easy to learn and easy to use. We've created a new interface in Geomatica Focus, which is our visualization interface, that will guide you through the steps for the image segmentation, classification, and subsequent feature extraction. For anyone familiar with our OrthoEngine product for orthomosaicing, we've got a workflow where we go through each of the steps in the process, and at each stage present you with a series of options and parameters that you can enter and modify to get the results that you need, and then save all of those into a project. So that's no different here for Object Analyst. In addition, this is a dynamic rule-based classification system. So in the interface, or in the image on the right-hand side of the screen, if you look in the lower left, you see a feature visualization panel. And in this case, we're looking at the mean value for each of those objects, and we're able to use those sliders to selectively include or exclude particular feature parameters from the segmentation. So if we'd like to get all the objects here with a mean between roughly 12,620 to 31,196, we know that we can select objects with this particular parameter. Now what that mean is, it could be a vegetation index, it could be an elevation value, but whatever it is, we're able to immediately see the results of our selection and apply those into the larger rule-based segmentation process. The next highlight is the proprietary algorithm that we've created. So it's been a couple of almost 2 decades now since feature segmentation became pretty common within the geospatial world. We've developed a new algorithm based on new processing techniques and modern hardware, which allows us to produce excellent results, a very robust and fast process that can generate segmentation at various scales. And that's what we see here. We've got objects that have been created at 2 different scales from the same image. And again, with the simple interface, we can just enter in a few parameters and run this to get those different results in 2 different tasks. In addition to the automation, which includes the ability to merge or dissolve like shapes into single objects, We've got easy object reshaping for manual object manipulation. So a click to merge automatic interface, which means you can select the objects singly or in groups and then assign them as being one larger object to simplify your overall segmentation. So again, this can be done automatically within the step-by-step process, or once these segments have been generated, can be merged manually to edit, or split back into multiple shapes as well. Moving on from segmentation into classification, we've added a new machine learning algorithm called Support Vector Machine. This is a supervised classification algorithm. We also have maximum likelihood classifier. And this produces what we feel are very good results. So I've got some accuracy results to show you in a moment. And in addition to the segmentation algorithms, both supervised and unsupervised, we have the training site editor, which you see on the right-hand side. So again, this is a new interface, very easy to use, which allows you to select the different classes, quickly give them names, color values, assign them or unassign them to new classes or subclasses, and mark them either as training sites or as checkpoints for accuracy assessment later on in the process, whereby they'll be used for comparison to the automatically selected classes. In terms of input data, because we've moved to the feature realm doesn't mean that the multispectral data is ignored. This is the basis for the segmentation. So any number of bands for satellite imagery or aerial imagery can be used for the spectral aspects of the classification. But to this, we can add just about any other layer that can already be used in the Geomatica interface. This could be digital elevation models, 3D features or building models, vegetation indices. And what this means is we can further refine our segments to reflect objects that, for instance, are a particular color and at a particular elevation, if we're looking for rooftops, perhaps, or base our segmentation on crop health by incorporating something like the vegetation indices and other crop health indicators. Provides a lot of flexibility, and with that interface, again, very simple to select these layers and refine the segmentation process and the rules that are used for this process. Now, I should mention all of this that we're seeing the overview of now will have be presented again in a dedicated webinar in 2 weeks' time. We're going to have a specific Object Analyst introduction and overview where we'll get into demonstrations, specific examples, and really look at how the process actually works. For today, I'm excited to just introduce the package and give you the overview of what it's capable of. Now, I mentioned accuracy earlier. Got some results here. So this is Landsat 7 Enhanced Thematic Mapper Plus data from South Africa. So we're automatically computing accuracy statistics for this classification. And then by comparing those to the training sites, we find accuracies on the order of 95% accurate, either with or without training sites. So very good automatic results and even higher accuracy for manual results. In addition, the signatures from the trained images can be used on other radiometrically normalized images, so that aids a bit in automation or for making larger project areas. So if you have a series of images that you can normalize radiometrically, you can apply the same segmentation rules and workflow to the multiple data sets and then compare those results. And just one final image here showing the classification output. So here, it's a good example of a mixed residential area where it's very clear to see the difference between the buildings, the grass, the trees. We can also identify shadow areas based on their relationship or proximity to the buildings or trees, and incorporate this vector layers or raster layers in here for the classification inputs and outputs. Okay, so that's the first part of the presentation. Before I continue on with the other new package, InSAR, and looking at OrthoEngine and other additions we made to Geomatica 2017. I want to pause for just a moment here to ask you a question about the OBIA software that you're already using. So I think Kevin's got that pull up on the screen now.
Yeah, we'll leave it up for a few more seconds. Just if you can let us know if you're already using something, that would be great to know. And so we'll leave that open just for a few more moments. Looks like most people have voted. And so I'll just count down from 3. So 3, 2, 1. Thank you. Go ahead, David.
Okay, thanks, Kevin. And thank you, everyone, for your answers. So now I'd like to continue with the second new package that we've added in Geomatica 2017, and that is Interferometric Synthetic Aperture Radar, or InSAR. So I'll give you, again, an overview of the new package, and we'll be having an in-depth presentation on this in 4 weeks' time. I'll provide all details about how to get these new packages and find more information at the end of the webinar today. So the main value of this new package is the accuracy. InSAR, as a technique, is able to measure very, very small changes in elevation, much finer vertical resolution than is available with other sensors. And here we're talking about millimeters or centimeters in difference. This means that, like other radar sensors, it can generate very accurate elevation models in all weather conditions. But because of the fine vertical resolution, it really is the best technology for mapping deformation across very large areas, across entire satellite scenes. Now, this deformation can have serious consequences for all sorts of natural features, drainage patterns, as well as construction stability, as we see to the right, where we have a local impact from perhaps urban excavation or water well digging. Can create stress and strain in the areas where there's higher deformation, as indicated in the upper right portion of the image there. You can see the color overlay from the interferometry is showing a high degree of subsidence in a particular location, but it makes it very easy to identify and, in this example or application, to send a crew out to manually inspect the damage that may have been done to the architecture or to the underlying infrastructure. Now that's very small scale. Deformation, of course, can have larger scale effects, like regional activities from mining, oil or gas extraction, or even larger scale effects like glacial rebound. So there's a variety of different applications for which InSAR is well suited, all of them having to do with measuring the subsidence or uplift primarily in elevation. Now that's a quick background on InSAR itself. The package that we've added to Geomatica 2017, again, we want to focus on making the entire rather complicated process accessible, not only for existing SAR experts, but for those who are new to the field of geospatial processing, particularly in the radar realm. So everything starts on the left with co-registration of the images. This means lining up any number of InSAR images over the same area so that we're able to compare them over time. And from here we generate the interferograms, which are going to show us the difference, initial difference in elevation. There's a number of sensors that are suitable for generating the interferograms, and some of them additionally can continue on with phase unwrapping and orbital adjustments that you see here, which turn that radar, those radar statistics and the interferometry into the actual elevation models and visualizations that can be used for deformation maps, the elevation models themselves, and as I mentioned, by stacking multiple images across time, we're also able to look at a temporal analysis. So there are a number of products that are generated within an InSAR package. The primary outputs are a digital terrain model showing absolute elevation, A cumulative deformation product, here we're talking about relative change between two images, and this interferometry could be collected from two passes from the same sensor or in a single pass if the sensor itself is capable of collecting InSAR data in a single pass. And finally, the deformation velocity. So with a stack of 3 or more images, we can measure the speed over time, and again, measuring in millimeters or centimeters of change over the course of weeks, months, or years. In addition to those primary products, there are a number of ancillary In SAR products that are useful for a variety of different, more in-depth analysis. I've highlighted with an asterisk there the first upper left image, the calibrated intensity. This is an output that is not common to all packages that may be available now. While it's not unique, it is a rather advanced function that we've decided to include in the InSAR package. It provides additional confidence and depth of analysis. Quickly going through some of the other layers, we can produce coherence layers to give an overview of the overall quality of the product you're producing. The interferograms themselves, the raw interferograms, are very sensitive and able to see the small changes in elevation as is. This can be generated from all the sensors that we support can produce these interferograms. From here, we start unwrapping or converting from radar space to geographic space, and we get for instance, the topographic phase, which is accounting for the viewing geometry of the sensor. We can correct in the bottom row there now, looking at orbital phase adjustment. So as a sensor could drift within millimeters while moving at many kilometers per second through space, we're able to correct for those small changes. And from there, being able to account for those errors, produce an adjusted DEM. So in this case, we're talking about a digital terrain model, very high spatial vertical resolution. And then using stable targets, so if your image is well aligned and the sensor geometry is good, we can also account for the atmospheric and phase and other random offsets that introduce noise into the results. So again, a little more analysis to provide a cleaner, more accurate result. Now, looking at multi-temporal stacks in particular, as I mentioned a couple times now, because we have a strong co-registration at the front end and can line up these images spatially, it makes it well suited for temporal analysis, taking a look at the change over time, in this case over the number of years, collecting multiple images over the same area. An example of the output map that we see here is taken over the span of about 6 months. And you can see even in this short time period, there's an effective change of about 5 centimeters because we're measuring 10 centimeters per year. And you can see those very purple, red and purple areas are at that speed range. But we don't have to measure an entire year to be able to predict these types of velocities. Indeed, in this example here, looking at a particular pixel, we can see we've got weekly readings over the course of 1 month and are able to measure millimeter changes for a particular pixel in this image stack. So we've added this new temporal charting tool into the InSAR package, so we are able to actually visualize the results that we can now get through this temporal analysis. So in addition to the again, easy-to-use workflow for InSAR, new visualization tools for analysis as well. Now, in terms of sensors, the end-to-end processing, including all of the phase analysis and all of the output products listed, are already available in our inaugural version for RadarSat-2 and TerraSAR-X. And we also can generate the interferograms for the additional sensors that you see on the right-hand column. Our goal in the short term is to expand the processing range of those sensors so that we're able to do the phase analysis and generate those additional output products for those other InSAR sensors. There are other sensors that radar sensors that may be suitable for InSAR processing, and in the future we can take a look at those as well. This is the primary sensor group that we're targeting for InSAR processing. If you do have any feedback on this, do let us know. Okay, so that introduces the two new packages, Object Analyst and InSAR. And now I'd like to look at some of the improvements we've made to existing packages, in this case, OrthoEngine. We've got some updates for our ortho and mosaic processing, primarily on the visualization, large project handling, and improved accuracy, namely through tie points on this last point. So the new model computations for improved accuracy. Here we're talking about not only a new model, a bundle adjustment method, so it's refined, slightly more accurate, but also a new two-pass tie point collection workflow with additional tie point thinning. So we're getting stronger points and don't collect as much noise. We'll take a look at each of these specific topics now. Now, in terms of visualization, this really gives we're talking about intuitive overview for your project itself. So we've added thumbnails into the image. Here we have a satellite project. You can see a number of overlapping images with the footprints outlined, but sometimes difficult to check which images are in the right place, what their cloud cover quality is like, and what the radiometric balancing is like. So before any model calculation or color balancing takes place, we can take a look at the layout and ensure, again, at a high level from quality control standpoint, that our project is well aligned and the input data is valid. In addition to the thumbnails, we also have reference layers that can be shown in the background. So here we have the satellite footprints once again, and in the background have added a panchromatic wide area mosaic as well as a vector roadmap. So now when we turn these image thumbnails on and off, are able to see how well they initially align, make sure that we've got our metadata imported correctly and that everything is looks like it's lined up correctly before we begin the GCP and tie point collection. Another visualization or project management tool that we've added is the Kappa rotation. This is particularly well suited for UAV projects, where when you're flying a quadcopter, for instance, you get to the end of a flight line, the UAV will rotate and may or may not take a photo at that point, or it may not rotate. It may just slew sideways from one flight line to the next and keep its orientation. So by adding a Kappa rotation tool, we're able to quickly identify, especially on the corners, which of these images is in the correct orientation, and if it isn't, rotate it counterclockwise or clockwise depending on the UAV orientation itself. You see we've got some presets there for 90 degrees and 180 degrees. If it's a different amount you need to rotate by, it should be close enough with the going to the nearest 90 degrees that then the tie points and ground control points can be collected from there on in. And speaking of tie points, I mentioned we have a new tie point collection method. So we now have a two-pass tie point collection process, and this main goal here is to reduce the number of weakly connected tie points, those that appear in only a single image pair, and increase the number of multi-connected tie points, those that appear in 3, 4, 5, even 6 overlapping images. Generally, these multi-ray tie points are producing a much tighter fit. They're better correlated across the multiple images, and they introduce less noise into the overall bundle adjustment. In addition to the two-pass method, we've improved our tie point thinning. So for images, particularly those where there's a high degree of overlap, we're now more intelligently removing the redundant points. So the overall effect here is not only more accurate model, but faster as well. Even though we're introducing a second tie point pass and more advanced tie point thinning, the fact that we've made some other improvements to the processing, and the end result is fewer tie points with a better connection means that the overall process is slightly faster than it was in 2016 as well. The last point here is the active and inactive point designation. So this has to do with the accuracy reporting and project overview, again, in terms of quality assurance and quality control. In the past, if you had a tie point or a GCP that was causing error within the overall bundle adjustment, the options were to remove it or set it as a checkpoint. We now have the ability to simply make those points inactive and immediately see what the effect on the model is. So recalculating the bundle dynamically as these individual or group of points are turned on or off to see the effect on the overall accuracy of your project. This means we're retaining all of the information that was collected, and if you, for instance, are adjusting the points in different combinations and have finally found a combination that works for the highest accuracy that you're able to obtain, we don't have to delete any of those other points from the file. They can be reintroduced later, and you can switch them on and off as you go. This is in addition to slightly better reporting methods. In this panel itself, there's been big improvements over the past 2 releases, as with our color balancing and mosaicing in our last release. So the focus in Geomatica 2017 has been on the accuracy and project handling at the beginning of the process, but to get the best of all of the updates we've made, those are included in the current release as well. Okay, now we'll move on to the final section of the new technology, which is sensors. We're proud to add new commercial sensors in every release that we have, and this is no exception. We're excited to partner with Planet and have the addition of the Planet Scope constellation of satellites in Geomatica 2017 now. Now, this imagery is available online via the web or through an API. For instance, through the Geomatica Developer Edition, you can use the Planet API to write a small script or application to search for and download images that you'd like to process locally. The data is already orthorectified, so in this case, the support we have for the product is the visualization, but also atmospheric correction. So there is some value add that we're offering within Geomatica 2017. A bit about the sensor itself. It's roughly 3.7 meter ground sample distance, so 3 to 4 meter resolution, and it's a 4-band sensor, so very useful and beautiful quality images, as you can see. Another sensor that we've added in Geomatica 2017 is Teleos 1. This is, again, for visualization, but in this case, orthorectification as well of level 1 and level 2 data. This is a 1 meter panchromatic sensor, but has a very high revisit rate. So it was designed to have a rapid collection of the same area in multiple passes. Makes it very useful for change detection, comparison, and temporal analysis, and works in Geomatica 2017, having added this new sensor as well. And one more new sensor, ZY3-2. So here we have a 2.5 meter panchromatic sensor with a 6 meter multispectral multi-channel sensor. For this satellite, we have full support, so orthorectification, pan sharpening, DEM extraction, and atmospheric correction as well in both the TIFF and RPC. TIFF format and RPC models for this sensor. It has a sibling sensor, ZY3-1. They're quite similar, and both look great in Geomatica 2017. So those were the new sensors. We have updates to some of our existing sensors. In this case, some of them are new formats or new distribution schema that are or metadata that's delivered with the sensor. This would be, for instance, the Pleiades and the Rapidi. They have new data versions, so if we read all of those. And for some sensors, we've improved the processing capabilities. For instance, CBERS 4 we've added atmospheric correction to this satellite processing. Likewise for Sentinel-2 with the level 1C product, we can now do atmospheric correction. And for TH1, we have now fully support pan sharpening and DEM extraction as well. So in addition to the new packages and the improvements to OrthoEngine, we have these new sensors and many updates as well. All right, we've got one more question for you before we wrap things up. I've got a short conclusion for you coming up, as well as slides that will, and information about where to get more information on any of these new technologies and the new product as well. So if I could ask Kevin to bring up the final poll of the day. We've got one more question for you all. So in this case, we're asking. Go ahead.
Sorry, David.
Yeah.
I was just going to kind of summarize there. So David is our product marketing manager, and as we define our roadmap for the future months and years, we're always curious to hear what our customers and partners and so on would like us to focus on. So this question asks about whether we should add new technology, make existing technology more efficient, work on speed, work on accuracy, or anything else. So if there's a particular area that you think is important and it's not listed there, you can type it into the questions panel, and we'll get that across through the interface. And yeah, it's very useful for us to get this kind of feedback, so that's why we do these polls. So we thank you very much for providing your input. I'll leave it open for just a few more seconds here. I'll count down from 3. So 3, 2, 1. Thanks very much for all of those of you who voted. And back to you, David.
Thank you, Kevin. Okay, just to summarize the overview today, 2 brand new packages available now in Geomatica 2017, Object Analyst for image segmentation, classification, and feature extraction. We've got InSAR, which is end-to-end workflow for subsidence and uplift analysis. Both of these new packages really with a focus on performance, accuracy, and ease of use. Updates in OrthoEngine related to project overviews and quality assurance, and a variety of new sensors and updated sensors as usual, and as we plan to do in all of our Geomatica releases to support you in whatever projects you may be working on. And I'm not sure, I seem to have jumped to earlier up in my presentation. Let me just get us back on track.
While David is doing that, make sure that if you have questions, if you're typing them in now, that would be great. Yeah, so if you have specific questions about Object Analyst or InSAR or anything else, be sure to type it in. We're going to do a Q&A in a few minutes here.
Right. So in terms of additional resources and availability, as Kevin has mentioned, Geomatica 2017 was released last week. You can go to getgeomatica.com to get your trial version and demo data right now available to test that out. It is a time-limited trial version, but there is no restriction in terms of the capability and the processing. So all the new packages and all of the complete set of functionality available in Geomatica is yours to evaluate. Now, in terms of the Geomatica webinar series, we have dedicated webinars coming up for both of the new packages. You can see the dates here. In 2 weeks from today, we'll be presenting an in-depth presentation on Geomatica Object Analyst. That's the segmentation and feature extraction package. And in 4 weeks' time, in mid-May, Geomatica InSAR. We expect to have some of our application experts available to answer questions during those webinars and provide a lot more information on how the new packages work and the kind of results and applications you can get out of them. It was very exciting and a pleasure for me to introduce the 2 new packages to you today, and thank you for your viewing on those. In addition to the webinar series and the trial version, you can always go to support.geomatica.com www.pcigeomatics.com for our full help center, where we've got not only tutorials on these packages, also access to past webinars, training resources, and some developer resources for the Geomatica Developer Edition as well. On our support page, we have the knowledge base and community search. So if you're looking for answers on a particular topic, you can look not only in our online help and other resources, case studies, and white papers that may have already been posted, but also to see if there's discussion or information posted from other community members. Okay, as Kevin mentioned, we'll have a bit of question and answer now. I see a couple of questions that have come up now, so let's just take a moment and I'll sort through. Okay, so I have a question here. Will Object Analyst be an optional license, or is it included with the standard license? Okay, so for commercial customers, Object Analyst and InSAR are new packages. They are add-on packages at additional cost. They're available in all regions, so you can contact your PCI reseller or contact PCI Geomatics directly to find out pricing for those two new packages. I should say that for education customers, yes, these packages are included in the education suite. So the Geomatica Education Suite for schools and for students as well now includes the Object Analyst package at no additional cost. So anyone under a valid support agreement can update their version to 2017 and they get access to Object Analyst. And for new customers, you will get, education customers get access to that package as well. And the InSAR has been added to the educational radar add-on. So in the past, we, 2016, had a radar add-on. It was additional. It's an additional cost item. It includes polarimetric processing, and now includes both the polarimetry and the interferometry. And I should just note that the addition of interferometry to the PCI suite really completes a long development process to bring fully functional radar processing for all users. Several years ago, we began adding new sensors and polarimetric processing. We then added support for compact sensors, which made the data more readily available for all of our users. Now that we've added the interferometry, it really is the up-to-date, that's the most current state of radar processing, and we've got our eye on future developments as well to ensure that anyone interested in radar can come to Geomatica or GXL and get a full suite of all the tools that may be needed for processing and analysis. Question here about how many layers Object Analyst can handle. With MLC, the maximum is 16 layers. That's in the question itself. I'm not sure on that specific answer. We will get back to you, but I would encourage anyone who has more technical questions about Object Analyst to please join us at our webinar in 2 weeks' time, where, as I mentioned, we hope to have one of the application developers available to answer those questions, but at the very least we'll have our application specialists, and we'll make sure that we have these questions forwarded on to them before we started. Question here about what kind of object geometry can be segmented, i.e. spatial and spectral. Okay, so I know we can classify standard spectral properties like the minimum, maximum, mean, and standard deviation of the objects for each of the bands that are being segmented. And for geometry, we've got, I know, compactness and elongation, and as well as shape, I guess the shape qualities of how circular or how rectangular the object is. But again, far more details available in 2 weeks' time. One more question here about radar sensors. Yeah, I mentioned that there were additional sensors that may be suitable for InSAR processing that did not appear on that list. That really has to do with the operational parameters of the sensor itself. I'm just looking back through my notes to see that. I can say again that although we've introduced the RadarSat-2 and TerraSAR-X for our end-to-end processing, our immediate goal now is to expand that sensor support for additional sensors that we saw on that list. Here we are, yes. So there's additional ones that may be suitable, but we haven't yet tested. Things like ALOS, ENVISAT, and SIR-C. But again, this is the first version of both Object Analyst and InSAR, and we can expect great advancements over the course of the year through service packs and updates to these new packages. Okay, I think that's all the questions that I see for now. Any technical questions about SAR or Object Analyst, I will forward to our application specialists in preparation for the upcoming webinars. And okay, all right. So I think that's it for the webinar. Thank you all very much for your attendance today and for your questions. On behalf of PCI Geomatics, on behalf of Kevin, myself, again, thank you for your attendance. Thank you for your support of PCI Geomatics. And if you do have any further questions, comments, or feedback, please do not hesitate to contact us on our webpage, www.pcigeomatics.com. Thank you, everyone, and enjoy the rest of your day or evening.